In this video, we are going to talk about how to complete the square. Completing the square is a method used in algebra to rewrite a quadratic equation so that it forms a perfect square and can be written in vertex form. So what that means is that we're going to take a quadratic in this form, ax squared plus bx plus c, and be able to rewrite it into vertex form. And once it's in vertex form, these values of h and k will very quickly tell us what the parabola vertex is, or that minimum and maximum value. So it's just a different way to write the equation to highlight the key information about it. Now, the steps to find or complete the square can be cumbersome, so I'm going to spell them all out here for you at the beginning and then walk you through an example. The first thing we're going to do is isolate the constant term in that quadratic equation. We're then going to find the number that we need to complete the square. We do this by taking half the coefficient of x, which is the b value, and squaring it. Then we will add that value to both sides of the equation, which will leave us with a perfect square trinomial. We can then factor that to be a perfect square and then solve for x, which will give us the roots of the quadratic. So let's take a look at it in action here. Here's my quadratic equation, x squared plus 6x plus 5 equals 0. We're going to go ahead with step 1, which is to isolate the constant term. In this quadratic, that's this positive 5, and to isolate it, we'll subtract 5 from both sides of the equation. That's going to leave us with x squared plus 6x equals negative 5. Notice we now have that constant term on the one side by itself. The second step is to find the number to complete the square. We'll do this by taking half of the b value and squaring it. In this quadratic, the b value, which is the coefficient in front of x, is 6. So if I take half of 6 and square it, that's going to leave me with 3 squared, which equals 9. Now I will add that value to both sides of the equation, which will give me a perfect square trinomial. So if I add 9 to both sides, I'll be left with x squared plus 6x plus 9 equals 4. Now that I have that perfect square trinomial, I can factor it, and this will help set me up to write this in vertex form. So if I factor the one side, that's going to leave me with x plus 3 squared equals 4. And I want you to remember this for when we go ahead and talk about the vertex form here in a minute. But we're going to go ahead and solve for x to find the roots of this quadratic. I'll solve by taking the square root of each side of this equation, which will leave me with x plus 3 equals positive or negative 2. If I subtract 3 from both sides to get x by itself, that will leave me with x equals negative 3 plus or minus 2. So, what does all of this mean? Well, with that x equals negative 3 plus or minus 2, that's given me the roots of this quadratic. If I take negative 3 plus 2, that gives me x equals negative 1. And if I take negative 3 minus 2, that leaves me with x equals negative 5. This quadratic has 2 roots or zeros for the equation. So this parabola will cross the x-axis at these 2 points, negative 1, 0 and negative 5, 0. Now, the vertex form that I was talking about, if you can remember when we were solving, I asked you to remember this piece. X plus 3 squared equals 4. This is going to help me write that vertex form that I showed you earlier. If I subtract 4 from both sides so that I have all the pieces on the one side together, I'm going to be left with y equals x plus 3 squared minus 4, which you can see is parallel to the form of that vertex form equation. The h and the k now are then going to be evident to us, which will tell us the minimum value of this graph. So the minimum of this parabola is negative 3, negative 4. And you might be wondering, well, wait, it has a plus 3 inside those parentheses. The vertex form is written as x minus h. So we're going to rewrite that x plus 3 as x minus negative 3 in order to keep the form the same. And that leaves us with the minimum value of negative 3, negative 4. So let's put it all together. Here, if I graph this quadratic equation, I have the roots of negative 1, 0 and negative 5, 0, and I know the minimum value is negative 3, negative 4. So this quadratic equation will look like this in parabola form. So, in summary, completing the square is a method that we can use to solve quadratic equations for 0 and the vertex. Thank you for watching, and if you're interested in learning more about TurtlEd, you can visit us at withturtled.com.